Hello, here we are again in GM Construct for another episode of WireMod Essentials. Today, we finally explore the steps toward creating a fully functional automatic turret, like the sentries in Team Fortress 2. We will be constructing it using the skills learned in past episodes, namely those skills learned in the mouse-aimed weaponry tutorial. Now as you see here, I have built us a frame on which we'll be building our turret. Floating in the sky is the beam that will rotate to face the player. What we're going to be doing with this beam is attaching it to the body below. It will attach like so, on top, and it will rotate freely. To achieve this, let's get out the Easy Precision tool and set the setting to ball socket. Now since the thickness of the prop is 5 units, make the offset -2.5 so that the prop is placed on its center. Okay, now in my case, I'm going to find the small green plus on the top of the triangle. If you build using the same props, you will want to find this place too. Okay, it's placed, and allowed to move freely. Mechanically, the turret is finished. Now we just need to add the wire system. Now, the first necessary device in any contraption that will log the location of players is the target finder. So let's place one of those now. Notice the setting scheme, with a range of approximately 300 and maximum bogeys set to 1. This will make it so that it automatically scrolls through players that wander too close, without us having to intervene. Okay, it's placed. Now, as always, we need a corresponding beacon sensor to gather values from the dynamic output of 1. In this case, all we'll need is the distance. Next, we need an entity position gate to gather the player's position in relation to the map. Okay, we have that placed. Now let's move on. Next thing we'll need is a comparison greater than gate. We're using this for the same purpose that we used it in the last tutorial. That is, to check whether or not the player's distance from the target finder is greater than 0. Now we need a gate vector subtraction to subtract the two vector values and get our angles, as we learned in the mouse-aimed turret tutorial. Okay, now that we have our gates placed, we need to move on to our components. First, place a GPS to gather the location of the back of the beam. Now, on the other end of the beam, let's place a vector thruster with normal settings. That is, maximum thrust 10,000, minimum thrust 0, and thrust multiplier 10,000. Now if you missed any of that, here's a complete list of the components we used. Pause the video if you need more time to look it over. Okay, now let's start wiring. The first thing we're going to want to wire is target and the beacon sensor to output 1 on the target finder. Next, wire entity from the entity position to the output of entity on the target finder. Now, moving on to the greater than, wire A from the greater than to the beacon sensor. Okay, now wire A from the vector subtraction to the GPS, and select the output vector. Now, wire B from the vector subtraction to the entity position gate. This will subtract the two vectors and convert it to angles. Now, wire mul, which stands for multiplier, from the vector thruster to the greater than, so that the multiplier for the vector thruster's force is either 1 or 0. Now, wire vector from the vector thruster to the vector subtraction chip, so that the vector receives its thrust rotation value. Okay, now it's following me, but we notice two different errors. The first error being that the beam is relatively wobbly. This is an easy fix. Get out the weight tool. If you don't have it, it's listed in the description. And set the beam weight to 1. Now the second error is we notice that the beam is pointing at our feet. This is because, as we learned before, our origin is our feet. So it's pointing at our origin. This too is a relatively easy fix. To make it more accurate, we want to point it at our body, right? So what we're going to do is place a second vector subtraction gate anywhere on the plate. Right here is fine. And then a constant value. Now notice that in front of the constant value it says vector with a colon. You can set the type of value that the constant value outputs by putting its type in a colon before the value. For example, if you want to output a string, simply put string before the value, as seen in the Hello World example above. Okay, now wire A from the new vector subtractor to the old one, and wire B to the constant value. And then wire vector from the vector thruster to the new vector subtraction gate. Alright, seems to work a lot better. Now basically what we just did was manually offset the z value of the aiming vector, pushing it up by subtracting it, so that instead of aiming at our feet, it aims at our body, making it a lot more accurate. And as you can see, it shuts off when we get out of range, because the greater than becomes 0. Now, this wouldn't be a true automatic turret if it didn't have teeth. So, let's place a gun on the end of it. Place the turret on the end of the beam that has the vector thruster. After freezing the vector thruster, of course. Okay. Now, as we discussed in the mouse-aimed weapon tutorial, it seems that the turret is less likely to fly around and get off target if it's welded to the beam. So unweld it from the thruster by R-clicking and weld it to the beam. Alright, now wire fire from the turret to the greater than, so it receives the value 1 or 0, and fires accordingly. Now, the last step in creating a successful, powerful, automatic turret is no-colliding everything on the beam with anything. Do this by getting out the no-collide tool and right-clicking everything on the beam, including the beam. That means the vector thruster, the turret, the GPS, and the beam itself. Alright, let's try it. Stupid CP is stupid. It works just fine. Now notice that the CPs turn red when they are targeted. You can turn this feature off by unchecking the Paint Target feature in the Target Finder options. My turn. Alright, that marks both the end of me and this tutorial. Thanks for watching, and of course, I hope this helped.